Welcome to this lecture on Elements of Mechanical Engineering. I am T.A. Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering from the College Institute of Aeronautical Engineering. In this course, we have seen the different systems which are going to be studied in mechanical engineering. So this course is all about the different components of mechanical engineering which are to be studied as a basic knowledge to civil and mechanical engineering students. Now this course is, in this we are studying the first module where we are going to see introduction and application of fossil, Hydel and solar energies. Okay. Now this course is divided into 5 modules. First module contains the energy sources and a little introduction to thermodynamics. Now we'll see what are the different energy sources. So what is a source of energy? Anything that can give heat or it can generate some kind of energy can be called as a source of energy. There are different types of sources available in the nature. They might be conventional or non-conventional energy sources. So the conventional energy sources are like wood, flowing water, fossil fuels, and there are some fossil fuels like petroleum, natural gas, coal, etc. So these are all comes under conventional sources of energy. So when we burn these objects, when we combustion is done on these objects, we will get some kind of heat or energy. And similarly, so these are also called as non-renewable energy sources because they are available in the nature. When we use them, we cannot renew them. They are not renewable. So that is why they are called non-renewable energy sources, because once they are exhausted, we can no longer use the conventional sources of energy. And then non-conventional energy sources. So these are the sources like solar energy, wind energy, biomass energy, ocean energy. And ocean energy, there are different kinds of there. Geothermal energy and nuclear energy. So these are some of the energy sources which are renewable because they are available in the nature. Even after using them for large quantities, still we can use them in future. They are very abundant so that we can renew them and we can use them many times. So we'll see what are the different sources of energy. There are renewable and non-renewable sources of energy, where renewable sources of energies are like geothermal energy, which is the energy that is coming out of the earth due to hot magma formation inside the core of the earth. So the temperature inside the earth's surface is very hot. We can use this temperature in order to make electricity. And similarly, we can use hydropower energy, where we can use water and the potential energy of the water can be converted into mechanical energy. Further, it can be converted into electrical energy by using a electric generator. And then solar energy. We can collect the incoming solar radiation. This radiation can be converted into electricity with the help of photovoltaic cells. And then biomass energy. Biomass energy is the energy which is produced in the form of gas, where the biodegradable materials are kept in a closed container for a short period of time. They will produce some kind of gases, and after decomposition, they will produce the gases. These gases can be used for combustion, and for producing the electricity also we can use these gases. And then wind energy. We can use the wind energy which is available in nature. We can harvest the wind energy with the help of a wind turbine. The wind turbines can be placed at very high altitude areas where the wind is very high. These wind turbines will rotate along with the air and they produce electric current. And non-renewable energy sources are like fossil fuels, which are petroleum based products, and then coal, which are produced inside the earth's surface by the decomposition of trees or old animals which are buried under the earth millions of years ago. And then nuclear energy. Nuclear energy is also non-renewable because it can be, once the reaction starts, it cannot be stopped because the nuclear reactions may be nuclear fission or nuclear fusion reactions. Okay, so this is also another kind of energy, and natural gases are there which are produced from the Earth's surface. So these are some of the non-renewable energy sources which are available in the nature, and they can be, we have to use them wisely because these are not renewable. Once they are completely exhausted, we cannot regain them in any manner. Now let us see the basic definition of a fuel. A fuel is a material that can be made to react with other substances and produce chemical or nuclear energies in the form of heat or work. So any fuel, for suppose I take the example of petrol. If I have petrol, which is a fuel, when it is combusted with the help of fire and in the presence of oxygen, it will produce lot amount of heat, and this heat can be used to run internal combustion engines, or they can be used to combust other any objects, and they can be used to produce heat. Okay, so that is when the fuel is combined with oxygen and the proper amount of oxygen is supplied to the petrol or any fuel, it will produce large amount of heat which will make the energy, or it will produce heat. So let us see some of the characteristics of a good source of fuel. Some characteristics are, it should have high energy output per unit mass or volume. Suppose I take an example of any fuel like coal and petrol. So when we take the examples of coal and petrol, what happens? Coal, 1 gram of coal can produce like 1 kilocalorie of energy, whereas 1 gram of petrol can produce like 10 to 20 kilocalories of energy. So based on this, we can compare that depending on the application, where the fuel is being exactly used, depending on that, we have to select a perfect fuel. When we want to produce energy in large amount, when we want to give the heat in a large quantity, then we can use coal. Or else if we want to use the very small amount of energy is required, like in the example of IC engines, where the engines are very small in size when compared to the furnaces or coke chambers which are used for coal. So the IC engines uses petrol or diesel. So the petrol is also called as gasoline in some places, even though it is, the formula is same and it will produce the same amount of heat when compared to diesel, when compared to petrol. And here the petrol is the one which can be used to produce heat in very small amounts also. Okay, when we compare the efficiency of petrol and coal, efficiency of the coal is very less when compared to petrol when they are used in small quantities, because petrol is highly inflammable, and even a small droplet of petrol can easily burn and it can produce some amount of heat. Whereas coal, when we are using coal for producing energy or heat, we need large amount of coal in order to produce a very little amount of heat, because the efficiency is very low when compared to petrol. So depending on the application, we should select what kind of petrol or what kind of fuel we have to select. Okay, so this is one point. Depending on the high energy output, we have to select the fuel, and then it should be easily available. The second important property of any fuel is that it should be easily available in the surroundings or environment, because any abundant fuel is very good for any application. So if any fuels which are not available in the nature, so they has to be used very wisely, because they will exhausted very fast. Okay, the fuel should be easily available in the environment, and then it should be easy to store and transport. See, when we want to transport uh, any fuel like coal, we will use locomotive wagons. And if we want to transport petrol, we will use tankers. So, the when we want to transport or store the fuel, they should be easily transportable, and they should be easily stored. Any fuel should have this quality. And then one last quality that any fuel should have is the fuel should be economical. So depending on the purpose or depending on the application, the fuel should be as economical as possible. They should not be overpricey, which makes them very less usage. We have to choose a fuel which is more economical in when we are buying them or we're selling them. So this is all about fuels, and characteristics of a good fuel sources are when fuel is combined with oxygen, they will produce large amount of heat. Okay, now let us go to the next slide. Here we'll study what is a fossil fuel and how fossil fuels are being utilized in the market today. So these are the fossil fuels are the fuels which are formed inside the earth from the remains of plants and animals after million years of storage or burial under the ground. So million years ago, the trees and plants, however, they will die one day and they will be covered in earth. They will be buried under the earth by nature, and after million years, they will convert it into coal. They will be converted into such a form they can be easily combusted. Now, these are called as fossil fuels. Some examples of fossil fuels are coal, petroleum, and natural gases. So these are some of the examples of fossil fuels. And some disadvantages of fossil fuels are: first disadvantage is they are being exhausted. Once we use them, we cannot renew them. And second important disadvantage of fossil fuels is they produce very harmful gases into the atmosphere, because all the fossil fuels are the combination of carbon. In any form, they will contain carbon. Whenever we made these fossil fuels for generating heat, if we combust any of these fossil fuels, definitely this carbon combined with oxygen will produce carbon dioxide. So this is the main disadvantage of using fossil fuels, where they will produce carbon dioxide and sulfur dioxide and other gases which are harmful to the atmosphere, and they may cause acid rains also. So the phenomenon of acid rains is happening because of this fossil fuels combustion. So burning of fossil fuels releases large amount of carbon dioxide, which causes global warming also. We know what is global warming. Global warming is the heating of the Earth's temperature because of the gases which are being trapped inside the atmosphere. These gases mostly contain the carbon dioxide and carbon monoxide, and they may lead to global warming. And these gases are in turn responsible for the depletion of ozone layer. Even ozone layer depletion also causes a great problem to the people who are living on Earth. So, greenhouse effect. Greenhouse effect is nothing but the Earth's temperature is rising day by day. So, what happens when the temperature of Earth rises from year to year? Every year, around 1 degree centigrade of temperature is increasing around the world because of this global warming. So, the main effect of global warming is, what are the sources of? We have polar ice caps. These polar ice caps will be, when the temperature rises around the polar ice caps, though these ice caps will melt down and they will eventually merge in the oceans. So, which increases the ocean level. So, every year the temperature is rising, as well as the water level of the oceans around the world are also increasing. So, this is the disadvantage of fossil fuels. And now, so these are some of the effects of fossil fuels, or some of the effects of the gases being produced by combusting or burning the fossil fuels. So first one is greenhouse effect, where when we produce large amount of smoke which contains carbon dioxide, carbon monoxide, sulfur dioxide, when these gases gets up into the atmosphere and they will merge, they will be trapped inside the atmosphere of the earth. When this happens, what happens is the solar radiation which is coming into the earth will be trapped inside the atmosphere, which makes the earth hot and hot. So what they causes is these gases will combine with the clouds. The clouds are generally a form of steam, and they are also gas. The clouds are also gases. So the gas molecules of the clouds and the gas molecules that are generated from the industries, which are very dangerous, they both combined in the clouds, and they will be somehow forms the acid rains. So the acid rains are the effects of a greenhouse effect. Because of this greenhouse effect, we are facing the problem called acid rain. So what are the effects of acid rain? When the acid rains fall in certain area, like they will cause damage to anything that is placed under the acid rain. Like they can cause damage to iron, they can cause damage to human being, they can cause burnings on the human skin or animals. So they may produce very bad effect on the people or living organisms which are living on the earth. And then second one is, due to the increasing temperature of the surrounding atmospheres, or due to the pollution that is being created because of the industries and the emissions from the industries. So the Taj Mahal, which was built back in the year 1400s or 1500s, the body of the Taj Mahal building was made with white stones, which are called white marbles. So due to the reaction of these white marbles with sulfur dioxide in the air, the color of the marbles is gradually changing. We can see nowadays the Taj Mahal is being turned into yellow color. So this is one side effect of the global warming, where we are producing the harmful gases which they mix with air and they change the color of this monumental building. And this one is, so this is greenhouse effect, where we see the trapping of hot gases, the trapping of the incoming solar radiation inside the Earth's atmosphere, and this is causing the planet to heat. And we can see the polar ice caps are being melted, and the water levels of the oceans are increasing day by day. Now we'll see what are the different sources, or what are the different ways in which we can generate energy. So here we are seeing a thermal power plant which is used to produce electricity, and this uses some kind of technique, and that we are going to study now. So here in a thermal power plant, we use water, coal as the raw materials for production of electricity. So see here, this is the first stage. We have a steam boiler inside which we will take a lot of water, and here we have a burner where we will make the combustion of coal. Okay, the coal is taken into a chamber and it is made to combustion, and this combustion produces a very high amount of heat. This heat is supplied to the water in the boiler. This boiler will boil the water, and this water is converted into steam when it reaches the boiling point. Now the steam at very high pressure, it is sent to the control valve, and there it is sent to the turbine, where the pressure of the steam will make the turbine rotate. So if you want to study this in detail, there is a separate course called thermodynamics or applied thermodynamics, where we can study the exact working of this turbines which uses steam power. So here the steam generated in the steam boiler is sent directly to the turbine, and the turbine will be rotated when the steam is passed through a nozzle at high speed, and this high speed moving uh, gas or steam which falls onto the turbine, it will make the turbine rotate. So this turbine is connected to a generator, which is a electromagnetic device, and this generator will produce electricity. See here, we have some other mechanism which can make use of the same water without losing a large amount, because water is very scarce in the earth's surface. So that is why we have to use the water in a clever way. So after the steam, it hits the turbine, the water will be sent into a condenser. I mean, the steam will be sent into the condenser where it gets condensed, and again the steam is converted into water. Now this water is again pumped into the steam boiler for next round of heating. So initially the heat which is coming from the coal will make the water boil and forms steam. This steam is sent into the turbine through a nozzle where it will rotate the turbine. The turbine will generate some electricity with the help of electric generator. Now this steam which is taken back into the condenser, and this condenser will cool down the steam, and this steam will be converted into water, and this water again it can be pumped back into the steam boiler for reuse. Okay, so it uses some kind of mechanism where the steam is being sent into a cooling tower where the temperature of the steam will be removed in a different stages by using a cooling tower and cooling pump. The steam will be converted into water again. So this is the basic working of a thermal power plant which produce electricity. Now this is another source of another power plant which uses hydraulic energy for producing electricity. So in this example, we can see the working of the hydroelectric power plant where the water is stored at a high elevation behind a dam. You know what is a dam? A dam is a structure which will stop the water from flowing. So the water stored behind this dam contains potential energy. So what does the potential energy has is, when the water is stored at very high altitude, it will have some potential energy in the form of mgh. M into g is the weight of the water and height is the h. H refers to the height up to which the water is stored. Now, this potential energy of the water, when the water is made to flow through a pipe, this pipe is called as penstock. Okay, this pipe is called as penstock, where the water will be flowing from very high altitude into this penstock, and at the end of the penstock we will convert a nozzle. It will contain a nozzle where the diameter of the nozzle will be very less when compared to the actual diameter of the pipe. Now what happens is, when the water is flowing through the nozzle, it will be coming out at a very high pressure. This high pressure water will be sent on to the turbine, and the turbine blades will rotate with the pressure that is being coming out of the water. Now when the turbine rotates, it will produce some electricity with the help of a generator again. Here we have a generator where it is directly shafted together with the turbine. So the turbine, when it is rotating, it will rotate the hydraulic generator, and the generator will produce electricity. This can be used by the domestic or for any industrial purpose. See, this is the basic working of hydroelectric power plant, where we are not using any kind of energy source. We are just storing the water behind a dam, and the potential energy of the water is being converted into mechanical energy for running the turbine. This mechanical energy is in turn converted into electrical energy, and it is used for usage in the industries or domestic purpose. So this is the working of hydroelectric power plant. Now this is biogas plant. So this is a fixed dome biogas plant where we will store the biodegradable material in a closed tank. So all the material which is biodegradable is stored in here, and when it is stored there, and some kind of chemicals will be added to the biodegradable material, and they will react with the chemicals we added, and a gas called methane gas, CH4 is its chemical formula, and the methane gas will be produced. So the methane gas, after the decomposition of the material, it produces gases, and this gas will be collected and stored in tanks where they can be used to produce heat by combustion. So the methane gas is very combustible, and heat can be produced by burning methane gas. So this is how a fixed dome type biogas plant works. And next one is wind energy farm. So we can see here the wind energy which is available in the nature. This can be converted into electricity by using these wind farms. Okay. So what does this wind farms contains? A wind farm contains a large number of wind turbines, where these turbines will be rotated with the help of wind. When air passes through these turbine blades, the turbine blades will rotate, and they will in turn rotate the generator which is attached to the turbine blades. Now the generator will produce electricity which is transferred or which is used by the people around the earth. So one disadvantage of using this wind energy is the wind energy may not be constant at every place. Not constant. Sometimes the wind will be high, sometimes the wind speed will be low. So depending on the speed of the wind, so the turbines will rotate. Whenever there is no wind, there is no production of electricity. When there is a high amount of air, or speed of the air is more in the area where turbines are being used, then the production of electricity will be high. So this is all dependent on the natural flow of air. So whenever there is a continuous flow of air in some areas around the world, so these places are selected for fixing the wind farm, where we can produce continuous electricity, not around the day, at least during some hours of the day. We can produce this electricity, and this can be used for immediate consumption, or they can be stored in batteries. So we can use battery where do we need energy. And next one is solar energy. So solar energy is the one which is abundant, which is readily available. Every day we can collect a large amount of solar energy by using some kind of solar panels. So most of the houses and industries are being they are using this solar panels for producing solar electricity. So simply we can install these solar panels on the roof, and we can get the bulbs or fans we can be using this solar electricity. So simply they will contain a photovoltaic cells, where it is very, when the sunlight falls on these photosensors, they will get some chemical reaction will happen, chemical reaction of the photoelectric cells, and this reaction will produce some kind of electricity. So the invention of solar panels is very good, because the solar energy is very abundantly available in the world. Not only on the surface of the earth, they can be used in space as well. Whenever there is a star, whenever there is radiation coming out of a star like our sun, so the solar panels can work. Even some spacecrafts like Cassini. So Cassini is a spacecraft which is being sent by NASA back in the year 1900, where this back in the year 1980s. So this Cassini spacecraft is still going in the outer space at a very high speed, and it's still sending some signals from very far. By now, the Cassini spacecraft has reached out to the outer layers of solar system, but still it is working, because it gets the radiation of the sun, which is taken by the solar panels it has, and this energy is used for the functioning of the spacecraft. So the spacecraft is not only exploring the outer solar system, and it has given some beautiful pictures of planets which we have never seen before. Okay, now the Cassini spacecraft is very popular for sending back the images from Pluto. So far we have no other spacecraft which has been sent near Pluto other than Cassini. This Cassini has sent us the images of Pluto, which are very beautiful and which are very interesting in the kind of space exploration. Now, the solar panels are useful in anywhere when there is a solar radiation. When we are near a star, we can get a large amount of solar radiation, and we can use this energy for many purposes, like we can produce electricity. We can heat water with this, where water heaters are now being installed with the help of solar panels. So these are some of the examples and applications of solar panels. And next one is tidal energy. So the tidal energy is the energy produced with the help of tides in the oceans. We know with the movement of the moon, when the moon is moving towards the earth, or rotation of the moon around the earth will create ripples or waves in the oceans. Okay, due to gravitational waves that are being generated by the moon. Now, these gravitational waves produces some kind of waves in any ocean we take. So these tides are used to produce electricity. Now, how this entire thing works? We'll see. We have some devices called floaters. So this thing and this thing are called as floating devices. These floating devices, when they are subjected to some kind of waves, they will move in oscillating direction. Like to and fro motion can be possible for these floating devices. Now these floating devices, which are in turn connected by using a special mechanism, where the to and fro motion of this floating devices can be converted into rotating motion of the electric generator. They can produce electricity. Here one disadvantage is that the electricity is generated in the form of pulses, because there is no continuous flow of the tides. The oceans does not get tides all the time. Whenever there are no tides, there is no electricity. When there are high tides, there is a large amount of electricity will be produced continuously. So another disadvantage is that all the generators are stored inside the water, where they are completely sealed from water, yet they can produce electricity with the rotational movement generated by the tides. Okay. So this is tidal energy, which is being used very rarely around the earth. And next one is geothermal energy. So the geothermal energy is a kind of energy which is using the electricity is produced with the help of geothermal heat. We all know that the inner surface of the earth is very hot. The inner surface of the earth is called core, and after that mantle is there. So different layers of earth will be there. So all these layers are very hot. They are so hot that they will produce the rocks and stones inside the earth's surface are converted into molten magma. Because of the high temperature inside the earth, there is no solid forms for rocks also. So this magma, whenever it comes in contact with water, the water gets evaporated easily. So that is this property of geothermal activity we are using for producing electricity. See here, the geothermal heat, or the heat inside the earth, when it comes in contact with the water. Here water is there. So this is all water, where the inner surface of the earth is very hot. This water gets heated and it is converted into some kind of steam. So this steam is used to run the generator or the turbine, very similar to thermal power plant, where in thermal power plant we have used coal to produce energy, and this energy is used to produce steam from boiling water. Similarly, the heat from the geothermal energy, this heat is given to the water. The water gets boiled and produces steam. the steam is made to fall on the turbine, where the turbine will rotate, and this is converted to a generator, and the generator can produce electricity. So we will use some kind of mechanism here where we can cool the water. We can cool the steam coming out of the turbine, and this turbine steam can be cooled and be sent back into the earth again, where we can produce the electricity again and again. Okay. So the inner surface of the earth is very hot. This temperature or this heat is being used to produce electricity. And next one is nuclear energy. So here the nuclear energy is where we will use some kind of radioactive element for producing electricity. Radioactive element. So the example for radioactive elements are thorium, uranium, etc. There are many other elements which are radioactive in nature. They can be used to produce electricity by some kind of chemical reactions like nuclear fusion and nuclear fission reactions. These are all chain reactions where the energy will be developed instantly, and if not controlled, they may cause damage to the entire nuclear power plant. Now we'll see the basic working of this nuclear power plant. Here we can see there is a closed chamber. Here there is a closed chamber inside which we will make the nuclear fusion reactions, where the nuclear radioactive elements will continuously react with each other and they will produce large amount of heat. Now this entire thing is done in a closed chamber, and this closed chamber is placed inside the water. Now what happens? Due to the enormous amount of heat being generated, the water around the radioactive element will get heated, and the water will be boiled. The boiling water will produce steam, and the steam will produce a high pressure energy. This pressure energy can be used by turbine, and it can produce electricity. The hot water or steam coming out of the turbine will be cooled and condensed, and this water is again pumped back into the nuclear reactor. So this is how the entire working will be done. See here, in thermal power plant, in a geothermal power plant, and nuclear power plant, we are using some kind of energy for boiling the water. Thermal power plant, geothermal power plant, and nuclear power plant. All the three things uses some kind of energy for producing boiling of the water. This boiling of the water creates some kind of steam which will move at a high pressure. This high pressure steam can be flown into the turbine, where the turbine will rotate and it can produce electricity with the help of a generator. Now see here, in this there is a cooling mechanism for the steam, where the hot steam coming out of the turbine is sent into a cooling tower. This is a cooling tower where it will be the extra amount of heat being removed from the steam, and the steam will be converted into water. This water is again pumped back into the nuclear reactor, where it can be reused. So that is all for today. We have seen what are the different energy sources, what are conventional and non-conventional energy sources, and after that we have seen the working of thermal power plant, nuclear power plant, geothermal power plant, biogas power plant, and a hydraulic turbine, hydroelectric power plant, where we will produce electricity with the help of the potential energy of the water. So this is all for today's lecture. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.